We are doing commission research, both exploratory research, often with governmental funding. We are doing cluster research programs with several partners, which we call multi-client projects. And we also do bilateral single-client projects, direct projects to single clients. And we do this in close collaboration with other institutes, universities, and also in EU-funded projects. And if we take the Pulp company is a measurement technology company, also based in Stockholm, Sweden, which you see here on the map, with the main office in Örnsköldsvik, northern part of Sweden, and also sales office in Sweden, and also sales office in Canada, Ottawa, Vancouver. And now also with a sales representative here in India, Mr. Tushar, I think he's in the audience here somewhere. So, Pulp is a commercial company, and here you see the reference list of installed units. And as you can see from the companies here, almost every one of them are based in Europe, except you have some companies that are from North America. You have Canfor Pulp here, for example, which is situated in Canada. So most of the customers are still based in Europe. The Pulp measurement device, if you do sampling, you do it online. You can do it from one or more positions. You can also do it take manual samples. And what can you measure? It depends what you want to measure. You can put in different modules here in the measurement device. The things that you can measure is the watering, for example, freeness, chopper, fiber dimensions like length, width, curl, fines, kinks, coarseness, shive consistency, brightness, pH, kappa number, dots, krill, and also fiber wall thickness. And the performance take less than 5 minutes per sample, except for brightness. One other unique thing with this measurement gate is that you can put in another module, an online krill sensor. And when you refine, you developed fibrils, or what we call krills, on the fibers, which you can see on the upper picture here, I hope. And by measuring with UV light, you can measure both the fibers and the krills that are developed during refining. But then, on the other hand, if you use ER, you only measure the fibers. And by dividing the UV and the ER, you get the krill fiber ratio. And why should you measure this? Often when you refine, you have a measure like the Chopper Riegler number. And here you can see an example on the left-hand side, we have the chopper against the tensile index. And as you can see from the picture on the left-hand side, there is not a linear correlation here. This was done for bleached softwood and unbleached softwood. But on the other hand, if you look on the right-hand side, when we have plotted the krill fiber ratio against the tensile index, the same points, you can see that we have a more linear correlationship with the krill against the tensile compared to the chopper. And I mean, by using this, it might be possible to save energy in the refining process. Furthermore, what you get out the result report, showing the consistency, brightest, also depending what models you have chosen, freeness, fiber dimensions, and shives, which makes you keep better control of your process, and you can also see if you have any fluctuation in your process. So, what about the Indian pulps? I will first start with two examples that we have been measuring on Scandinavian pulps. In those two pictures, on the left-hand side you see a hardwood pulp, and on the right-hand side you see a softwood pulp. On the y-axis we have the fiber width, and on the x-axis we have the fiber length. And as you can see from this picture, the hardwood compared to softwood give a different fingerprint if you compare them, hardwood and softwood. So how can you use this information in order to model when you mix in order to predict how much softwood you have in the pulp? So we used the Invensia pulp mix model in earlier work. Here we have the known share of standard Scandinavian softwood on the x-axis, which we mix together. And if you look on the y-axis, that is what we estimate with the pulp mix model. And as you can see from this picture, it's a very good correlation what we can predict regarding the mix and what the known mixture is. So, could you use this in the same way as for the Scandinavian softwood and hardwood? Yes, the answer is yes, you could. Here we mixed eucalyptus and bagasse, and on the x-axis we have the known share of bagasse, and on the y-axis we have the estimated amount of bagasse with our pulp mix model at Inventia. And you can see that we have a nice and smooth correlation, what we can estimate from the mix and what the real number is. And the same if we continue for Causserinia. We have the known share of bagasse on the x-axis again, and we have the estimated amount of bagasse here on the y-axis. And you can see that we nearly get the same smooth correlation as for eucalyptus. And further on, we also did a 3-component model where we had eucalyptus, Causserinia and bagasse. So we mixed 50-50 split between eucalyptus and Causserinia here. And also for that case, we have the known share of bagasse on the x-axis and the estimated amount of bagasse on the y-axis. And as you can see, we also find a quite good correlation even here.